Good morning, students. Today we will discuss an important application of the Laplace transform, that is solution of ordinary differential equation. For solving ordinary differential equation, we use a result. That result is known as Laplace transform of derivative. Laplace transform of derivatives. By using this result, we can easily solve the ordinary differential equation. The result says that if Laplace transform of function f of t is equal to f bar s, Laplace transform of function f of t is equal to f bar s, then the result says that Laplace transform of the function f dash t, that is f dash t is the derivative of the function f of t, derivative of the function f dash t is equal to, the result says that s into f bar s minus f0. f0 is the initial condition. Similarly, Laplace transform of f double dash t, Laplace transform of f double dash t is equal to s square f bar s minus s f0 minus f dash 0 minus f dash 0. This is the Laplace transform of the second derivative of the function. Similarly, Laplace transform of third derivative is equal to s cube f bar s minus s f0, s square f0 minus s f dash 0 minus f double dash 0. This is the result for the Laplace transform of the third derivative of the function, and so on. By using these results, we can easily solve the ordinary differential equation. Here we take when f of t is equal to y, then when f of t is equal to y, L of f of t is equal to L of y. L of y denoted as y bar. When we take f of t is equal to y, then Laplace transform f of t is equal to L of y, that is represented as y bar. Then the formula will become changed as L of y dash, that is derivative of the function y dash is equal to s into y bar minus y0. S into y bar minus y0. When we use the problem, we use this formula. L of y dash is equal to s into y bar minus y0. Similarly, L of y double dash is equal to s square y bar minus s y0 minus y dash 0. This is the derivative of the second derivative function L of y double dash. Similarly, L of y triple dash is the third derivative, s cube y bar minus s square y0 minus s y dash 0 minus y double dash 0. By using these results, we can easily solve the ordinary differential equation. Then we can do some problem based on this result. You must remember these results: L of y dash, L of y double dash, L of y triple dash, etc. Then we can do some problem based on this result. The first problem is solve the method of Laplace transform y triple dash plus 2y double dash minus y dash minus 2y is equal to 0. The given conditions given: y0 is equal to y dash 0 is equal to 0 and y double dash 0 is equal to 6. We can do this problem. This is an ordinary differential equation. We can solve this problem by using Laplace transform technique. For that, first we take the equation y triple dash plus 2y double dash minus y dash minus 2y is equal to 0. This is the ordinary differential equation. y0 is equal to y dash 0 is equal to 0 and y double dash 0 is equal to 6 is the initial conditions. Here we take Laplace transform. We take Laplace transform on both sides. To solve the ordinary differential equation, the first step is the taking Laplace transform on both sides. That is L of y triple dash plus 2 into L of y double dash minus L of y dash minus 2 into L of y. Right hand side L of 0 is equal to 0. Therefore, we take Laplace transform on both sides. Take Laplace transform both sides. In L of y triple dash, we have a formula, we have a result. That result we can apply here. That is s cube y bar minus s square y0 minus s y dash 0 minus y double dash 0. This is for L of y triple dash. L of y triple dash is equal to s cube y bar minus s square y0 minus s y dash 0 minus y double dash 0 plus 2 into, then apply the formula L of y double dash. L of y double dash is equal to s square y bar minus s y0 minus y dash 0. Then minus L of y dash. L of y dash is equal to s into y bar minus y0. Put in the bracket. Minus 2 into L of y is equal to y bar. That is equal to 0. Here we take the Laplace transform on both sides and take L of y triple dash. Apply the formula s cube y bar minus s square y0 minus s y dash 0 minus y double dash 0. Then second case 2 into L of y double dash. 2 into, apply the formula s square y bar minus s y0 minus y dash 0. Then third case 2 into L of y dash, s into y bar minus y0. Then 2 into L of y, 2 into y bar equal to 0. This is the first step. The second step, you apply the conditions. Here the conditions are given as y0 is equal to y dash 0 is equal to 0 and y double dash 0 is equal to 6. This is the initial conditions. When we are applying the conditions, s cube y bar minus s square into, given that in the problem given that y0 is equal to 0, we put it as 0 here, minus s into y dash 0 is given as s into 0 minus y double dash 0 is equal to 6. Therefore, in the first L of y triple dash, we substituting the initial condition. Similarly, plus 2 into s square y bar minus s into y0, y0 is equal to 0 minus y dash 0, y dash 0 is again 0. Then minus s into y bar, s into y bar minus y0, y0 is equal to 0. Then minus 2 into y bar is equal to 0. In this step, we apply the given conditions. In the problem, some conditions are given. We apply the given conditions. S cube y bar minus s square into 0 minus s into 0 minus 6 plus 2 into s square y bar minus s into 0 minus 0 minus s into y bar minus 2 into y bar is equal to 0. Then removing the bracket. S cube y bar, here this term is 0. Then this term is 0. The s cube y bar minus 6 plus 2s square y bar minus s y bar minus 2y bar is equal to 0. Removing the bracket. Then here we take s cube plus 2s square minus s minus 2 into y bar. Then right hand side 6. Therefore, y bar times taken as left hand side, the constant term taken as right hand side. Therefore, s cube plus 2s square minus s minus 2 into y bar equal to 6. Therefore, y bar is equal to 6 divided by s cube plus 2s square minus s minus 2. S cube plus 2s square minus s minus 2. That is, y bar is equal to 6 divided by this s cube s square into s plus 2 minus s plus 2. Here we take s cube plus 2s square taken outside of s square into s plus 2 minus of s plus 2. That is, y bar is equal to 6 divided by s square minus 1 into s plus 2. Then we get a function, numerator is equal to 6 and denominator equal to s square minus 1 into s plus 2. Then we y bar is equal to y bar is equal to L of y. L of y is equal to 6 by s square minus 1 into s plus 2. Therefore, y is equal to L inverse 6 by s square minus 1 into s plus 2. Therefore, here we find the inverse Laplace transform of the function 6 by s square minus 1 into s plus 2. These are the following steps. First we take the Laplace transform on both sides. Then applying the initial conditions. After applying the initial condition, we reach the position L of y equal to 6 by s square minus 1 into s plus 2. Therefore, y equal to L inverse 6 by s square minus 1 into s plus 2. Then to find the inverse Laplace transform of the given function, we convert this function as a partial fraction. Then we convert this function as a partial fraction. For that, we take 6 by s square minus 1 into s plus 2 is equal to 6 by s minus 1 into s plus 1 into s plus 2. That is equal to a by s minus 1 plus b by s plus 1 plus c by s plus 2. This is the first method of the partial fraction. By the first method of partial fraction, 6 by s minus 1 into s plus 1 into s plus 2 can be taken as a by s minus 1 plus b by s plus 1, c by s plus 2. Therefore, 6 is equal to, multiplying the denominator of the left hand side, a into s plus 1 into s plus 2 plus b into s minus 1 into s plus 2 plus c into s minus 1 into s plus 1. Or multiplying both sides, denominator of the left hand side. Denominator of the left hand side is equal to s minus 1 into s plus 1 into s plus 2. Then the left hand side becomes 6. The right hand side becomes a into s plus 1 into s plus 2 plus b into s minus 1 into s plus 2 plus c into s minus 1 into s plus 1. This is the first method of the partial fraction. Then we can find the value of a, b and c. We have to find the value of a, b and c. To find the value of a, b and c, first we put s is equal to 1. When we put s is equal to 1, the left hand side becomes 6. The right hand side becomes a into 1 plus 1, 2. 1 plus 2. 1 plus 2 is equal to 3. Plus, this term will be 0, this term will be 0. Therefore, 6 is equal to a into 6. Therefore, a is equal to 1. The value of a is equal to 1. First constant, the value of a is equal to 1. Then to find the second value, put s is equal to minus 2. When we put s is equal to minus 2, 6 is equal to a into the 0. First term will be 0. The second term, b into, again it will be 0. Then plus c into minus 2 minus 1. Minus 2 minus 1 minus 3. Then minus 2 plus 1, then minus 1. Therefore, 6 is equal to c into 3. Therefore, c is equal to 6 by 3, that is equal to 2. Therefore, the value of c is equal to 2. Similarly, when we put s is equal to, next constant, put s is equal to minus 1. When we put s is equal to minus 1, the left hand side becomes 6. Therefore, first term will be 0. Then second term, b into minus 1 minus 1, that is equal to minus 2. Minus 1 plus 2, that is equal to 1. Then third term will be 0. Therefore, 6 is equal to b into minus 2. Therefore, b is equal to 6 by minus 2, that is equal to minus 3. Therefore, value of b is equal to minus 3. Value of b is equal to minus 3. Then, after finding the values of the constant a, b and c, then we can take the inverse. Therefore, L inverse 1 by s minus 1 plus minus 3 into L inverse 1 by s plus 1 plus 2 into L inverse 1 by s plus 2. That is y. Therefore, L inverse 1 by s minus 1, the value is equal to e raised to t minus 3 into e raised to minus t plus 2 into e raised to minus 2t. Therefore, the answer is e raised to t minus 3 into e raised to minus t plus 2 into e raised to minus t. This is the value of the y. Therefore, we solve the ordinary differential equation by using Laplace transform technique. By applying the initial condition and taking Laplace transform on both sides, we solve the equation and finally we reach the point y is equal to e raised to t minus 3 into e raised to minus t plus 2 into e raised to minus t. This is the one of the important application of the Laplace transform. Here we do another problem. Okay, clear. We can do one more problem. Next problem. Next problem. Y double dash minus y is equal to t. Y0 is equal to 1. Y dash 0 is equal to 1. This is second problem. This is another ordinary differential equation. Y double dash minus y is equal to t. Y0 is equal to 1. Y dash 0 is equal to 1. In this problem, right hand side is not equal to 0. Right hand side is another function, that is t. Here we can solve this ordinary differential equation and we can find the value of y. For that, similarly, just like previous case, y double dash minus y is equal to t. Y double dash minus y is equal to t. Taking Laplace transform on both sides, L of y double dash minus L of y is equal to L of t. We are taking Laplace transform on both sides. Y double dash minus y is equal to t. Taking Laplace transform, L of y double dash minus L of y is equal to L of t. L of y double dash is equal to s square y bar minus s y0 minus y dash 0. L of y double dash is equal to s square y bar minus s y0 minus y dash 0. L of y bar is equal to L of t. L of t, we know that formula. L of t raised to n is equal to n factorial by s raised to n plus 1. By using that formula, here n is equal to 1, therefore 1 by s square. Therefore, we take the Laplace transform on both sides. Y double dash minus y is equal to t. Taking Laplace transform on both sides, L of y double dash minus L of y is equal to L of t. L of y double dash, by using the result, L of y double dash is equal to s square y bar minus s y0 minus y dash 0. Therefore, s square y bar minus s y0 minus y dash 0 minus y bar is equal to 1 by s square. That is s square y bar minus y0. Y0 is equal to, given that y0 is equal to 1. S into 1 minus y dash 0 is again 1. Minus y bar is equal to 1 by s square. After taking the Laplace transform on both sides, we applying the basic conditions, initial conditions. When we apply the basic conditions, s square y bar minus y bar is equal to s plus 1 plus 1 by s square. S minus s becomes plus s, minus 1 becomes plus 1. Therefore, s plus 1 plus 1 by s square. Therefore, s square minus 1 into y bar is equal to s plus 1 plus 1 by s square. Therefore, y bar is equal to s plus 1 by s square minus 1 plus 1 by s square into s square minus 1. That is 1 by s minus 1 plus 1 by s square into s square minus 1. Therefore, this is the y bar. Therefore, L of y is equal to 1 by s minus 1 plus 1 by s square into s square minus 1. Therefore, when we take y is equal to L inverse, when we take the L inverse of the function, we get the value of y. For that, first we resolve into partial fraction. 1 by s square into s square minus 1. Resolve into partial fraction. For that, 1 by s square into s square minus 1. Here we apply the third property in partial fraction, as plus b divided by as plus b divided by, this can be written as s minus 1 into s plus 1. S square minus 1 can be taken as s minus 1 into s plus 1. Therefore, as plus b by s square plus b by s minus 1 plus c by s plus 1. To find the inverse Laplace transform of the function 1 by s square into s square minus 1, we resolve into partial fraction. Then third method of partial fraction says that 1 by s square into s square minus 1, 1 by s square into s minus 1 into s plus 1 is equal to as plus b by s square plus b by s minus 1 plus c by s plus 1. Then we can find the value of as plus b plus c plus d. As plus b by s square plus c by s minus 1 plus d by s plus 1. To find the value of as plus b into s minus 1 into s plus 1 plus c into s square into s plus 1 plus d into s square into s minus 1. Then we can find the value of a, b, c and d. First we put s is equal to 1. When we put s is equal to 1, left hand side becomes 1. Therefore, the first term will be 0. The second term will be c into 1 into 1 plus 1, 2. Therefore, the third term will be 0. Therefore, the value of c is equal to 1 by 2. The value of c is equal to 1 by 2. Then, similarly, we can find the next value. Put s is equal to minus 1. When we put s is equal to minus 1, 1 is equal to the first term will be 0, minus 1 plus 1 0. The second term it will be 0. The third term d into s square is equal to 1. Then minus 1, third term will be 0. When we put s is equal to minus 1, we didn't get the value. Therefore, we take equating coefficients of s cube. Equating coefficient s cube, 1 is equal to as cube. Therefore, a plus c. And equating coefficients of s square, we get 1 is equal to left hand side is equal to 0. Similarly, we can find the value of a, b and c and d. Therefore, finally we get the value of y is equal to e raised to t 1 by s minus 1 plus 1 by s square minus 1 minus 1 by s square. That is, when we are applying the formula L inverse, that is equal to e raised to t plus this is sin ht minus 1 by s square, that is equal to t. This is the net result, e raised to t plus sin ht minus t. When we are applying the partial fraction method, we can split into 1 by s minus 1 plus 1 by s square minus 1 plus minus 1 by s square. The finally we reach the point y is equal to e raised to t plus sin ht minus t. That is, the given equation y double dash minus y is equal to t, given condition y0 is equal to 1, y dot 0 is equal to 1. Applying the Laplace transform technique, we reach the point L of y. From the L of y, we can find the y bar. L of y is equal to y bar. When we take the inverse Laplace transform, finally we reach the point y is equal to e raised to t plus sin ht minus t. Okay, thanks.